Okay, good morning. Welcome to this seminar presentation for today, which is entitled Introduction to Repetition in the Python Programming Language. My name is Gift Stoner from the Physics Department, and the objectives for our presentations are as follows. So we want to look at how to implement repetition in Python. There are two main ways of doing that. The first one is to use something called a while loop, and the second one is to use a for loop. So basically that's what the main focus of our presentation is going to be, on these two structures or constructs. So we'll look at the two ways of running a while loop, using a counter and also using a quit value, which is also known as a sentinel value. Then we'll also see how you can skip certain outputs, because sometimes you don't need to print everything. So there is a way you can skip certain outputs. Then we'll also look at how to exit a while loop. Then we'll see how you can use a while loop to move things around from a list. And also we'll see how to use for loops to go over lists, tuples, ranges, and dictionaries. So when it comes to yes.
The last class we learned about else, if, and
yes, decision making, yes.
And inside so many elif
yes.
and all.
Yes. So
now this is a separate loop.
This is a separate part. This is just repetition.
Repetition.
Yes. Okay. So repetition is implemented in two main ways, using while loops and also for loops. Other programming languages have got other structures which they use, but these are the two main ones for Python. Now, when it comes to a while loop will eventually have to end. And there are two ways of doing this. You can control a while loop using something called a counter. This is basically a variable you initialize at the outside the while loop before it starts. Then inside the while loop, you either increment this particular variable or you decrement it, you reduce it until the condition you're testing becomes false. So basically the structure for a while loop is as follows. You start with the keyword while, then followed by the condition which you're going to test. Then after you've finished writing the condition, there's a semicolon here. So the semicolon here tells Python that you have finished writing your condition and your while loop, and thereafter what comes next is this particular code which is supposed to be executed if this particular condition is true. So in this particular case, outside here, at the beginning here, outside here, you can initialize a variable called a counter, which with a particular value, then you can either increase this particular value inside or we can decrease that. So here we have an example of a simple code which is going to print numbers from 0 to 9. So basically, this print statement says the purpose of the program basically is to print numbers from 0 to 9. Then this is the counter which we have here. So here the counter variable is being initialized to 0. Then we start our while loop here. Then we check. So this is the condition here. We check if the value stored in the counter is less than 10. And we end our condition here. So basically that makes that part there. So if this particular statement is true, then inside, these are the things we want to do. So we want to print out the counter, but also you need to have a statement. If you're using a counter, you need to have a statement like this one, which is going to increase the counter the way you want. So in this particular case, we're increasing it by 1, or you can increase it by 2. Or if the counter was initialized to a larger number, you might have to decrease the counter until the condition you have set here becomes false. So as long as this particular condition is true, then the code, which is this counter, print counter, is going to be run, and the counter is going to be incremented by 1 until the counter becomes 10. At such a point, 10 less than 10 will be false, then this particular code will stop running. So it will print out the following. So this program prints numbers from 0 to 9. So you will print out this 0, 1, 2, 3, 4, up to 9 here. And the reason why 10 is not printed out is because when the counter is increased, when it's at 9, then it's increased 9 plus 1, that gives us 10. Then when the while loop checks this condition, 10 less than 10, this condition becomes false. So it doesn't print out the counter when it has 10. Yes.
Mr. Sichone, I'm just like this same thing we can do it with the if also. Like
With it?
setting the counter, like if the counter less than 10, do this, that the one that we learned in the last week.
That is decision making. So you're saying if a particular thing is this, you do this. This is repetition.
Yeah, this is also why this condition is satisfied, you do this.
Yes.
So
It's,
what's
it's,
the
it's, some
difference
kind,
actually?
it's also some, you can say some kind of slightly decision making, but
Because this should work
the
with
focus,
the other one also.
but the focus here is repeating something.
Okay.
Yeah, there might be something you want to repeat over and over and over and over. So basically, the code inside there, which in this particular case we are just printing. We're not really, we're just printing out this particular, the value of the counter.
So this line of
Yeah.
the one increment counter by one, counter is equal to counter plus
It is
one.
0 plus 1.
So 0 plus
plus
1 is.
1.
One.
Then 1
One
plus
is
1.
then
So
one is.
okay, so you start from.
We start with 0.
Oh, you start from 0.
So here we check. So here we
yeah.
check. So we initialize here outside. Then we check here counter less than 0. So right now counter has got 0. So 0 less than 10 is true. So when this is true, then it prints out the value of counter. So it
And
prints
then
out
it
the.
automatically stores
Yes.
in the
So
counter.
it starts with this one. So it's a print counter. So it
Yes.
starts with this one.
Yes,
Yeah.
yes.
Then after that starts increasing.
Yes.
So this is kind of like in a loop, right?
Yeah,
When
in
you
a
are
loop, yeah.
Yeah, this is it's a while loop.
in a
Yes.
certain range.
Yes.
Yeah.
So,
Does the for loop work as well?
Yeah, for
Yeah.
loop can also work as well.
yeah, because
So-
my question is if counter is 0, next if we write if counter less than 10, print.
But if we want to print, let's say numbers up to 100, how are we going to?
Then you can increase same way counter equals counter plus 1 inside the if loop. That also will work.
So
isn't
that
it?
works with for loop, Dr. Rosa. Yeah.
Not with if.
If the if would work also, but maybe we will have to do it repeatedly.
Maybe you have to write a lot of them.
Yeah.
You have to, yeah.
So,
So this one is
So
but this
a lot
one
of
will just be one
nested.
loop.
If which is something we don't want to do. Yeah. However, if you didn't want to start from printing from 0, you want to start printing from 1, then you can swap this line with this one, so that the counter, before the printing is done, the counter is incremented by 1. So you start printing from 1. So when you swap them, then this is the result you have here. So you have the same program here. Now we're saying the program will print 1 to 10. So counter equals to 0, then counter less than 10, this is true. Then we don't print out, but we increase the counter by 1. So 0 plus 1, now it becomes 1, the counter becomes 1. Now we print out the counter. When we do that, now we end up with 1 up to 10.
So the program is, it follows line by line.
Yeah, increments.
Yeah, that's what.
According to the code, the way it comes in the, for example, just scroll down. If you move this thing here, this line thing here, what will happen?
If I move what? Which one?
This line,
Mm.
under here.
That's what we- that's the first one, that's the
That's
first-
the first one.
that's the first
So
one.
That's what I'm saying now.
That's what this one.
That's what that.
So if we brought here,
Yeah, kind of like.
so when it's executing, it's execute line by
Line
line.
Yeah, line by
On-
line. So it repeatedly executes these two lines like that. Okay. So that's what you would get if you wanted to start from 1. And in this particular case, the 10 is printed out when it's at 9. When it's at 9 here, then you increase by 1, it becomes 10. Then it gets printed out. Now when the counter is 10, then this particular one here, counter which is 10 less than 10, is going to fail. But when it fails, by the time it fails, it has already printed the 10. Yeah. Okay. So basically,
Mr. Sean,
yes.
just this one where the program executes line by line, when it comes to large projects, you find that the programs take pretty too long a time. Because that's
Because it's moving,
Yeah.
looping.
and I think you are object oriented. programming.
Yes, they use object-oriented
Yeah, so that
programming.
one you do it in modules, and therefore long programs pretty takes just short time to.
Yeah. And just to preempt, the whole build-up of everything we're doing is so that we end up with object-oriented programming. So at the end of the lecture series, we're going to have object-oriented programming so that we can do the things Dr. Milo just mentioned. So this whole thing is a build-up to that, because you need this kind of stuff, functionality, even when you're doing object-oriented programming. Okay.
How would you, what do you call it? Those diagrams you draw when you are starting, if, while, go.
Those are called what's this?
The flowcharts.
Unified, unified modeling language flowcharts.
Okay.
Yeah.
It would be very good as a small thing or
In this one,
yeah.
this it's just a small thing.
A small
Yeah. Just a small thing. Okay, I think we've got attendance request. Okay. The next bit is sometimes you don't want to print everything, like the way we're printing all the values which come. Maybe the only thing you want to print are just even numbers. So if you want to print even numbers, then before you print the counter, you need to check if the number you're about to print is even or not. Then if it's even, then you print it. If it's not, then you don't. So in this particular case, we are going to see how we can skip certain outputs. And the way we do that is, of course, is to, now we have to make a decision. So now we're beginning to embed decision making in our loop. So here we start out with counter 0, then we check if the counter is less than 10, then here we increment the counter. Then after we increment the counter, we check if counter is divisible by 2. So this bit here is basically checking what is the remainder of counter divided by 2. This gives us a remainder. So if the remainder is equals to 0, then we print the counter. Else, we don't do anything, just say continue. So it just goes back to that.
Do you also call that as a modulus for checking the?
Yes.
That's a modulus.
That's modulus, yes. Most of the functionality which Python has is directly obtained from C and C++. So basically, Python is like a much easier, a kid's version of C or C++, especially C++. You find literally almost everything the same. There are certain things which are in Python which are not in C++. Yes.
What's the difference between an equal sign and double equal sign?
Double equal sign is for equal to. Then one equal sign is an assignment.
Assignment.
You want to store a value in a particular variable. So both languages use double equal signs for equal to and one equal sign for an assignment. Yes, Dr.
So my question is it possible to write like, instead of checking like this counter equals counter plus 2, so that it, I don't know, is it possible or is it always incrementing by 1?
No, you can increment by 2. You can increment by how much?
Then it is 0 plus 2, then 2 plus 2, 4, so it's automatic.
For example, let's say it's checking 1, right? And then you increment by 2.
Increment by 2.
It will go to 3, which is not an even number.
Yeah, which is not.
So that one would not work perfectly well.
No, then that won't be printed, isn't it?
No,
So we're saying it has to print an even.
It has to print only even numbers.
okay, yeah, it will not.
No, I'm just asking if we set the counter to 0.
So in this particular case, when you run
counter is
this,
counter plus 2, then
so
0
you
plus 2,
have,
then 2 plus 2, 4,
You have
4
this.
plus 2.
Yeah, that would work.
And then print the counter, does it work the same?
It
It should work.
Yes.
It should work, isn't it?
yeah, there's more than one way you can implement something. So here we're just trying to show how you can skip certain outputs by you check for a particular decision. Then if that's the case,
So if you want odd number, you just put 1 there.
Hmm.
1.
Yeah,
that
set
is
the
also
counter as
another-
counter to 1 as.
So where I say counter divisible by 2 is equal 1.
So that's the bit about programming,
Yeah.
because what you instruct instruct it. That's what it does.
Yeah.
So if you instruct it wrong thing and you are not checking,
Checking.
like this modular sensation is implementing. That's the function that will help you to check the way mathematics works. But if you define your own mathematics, then it will also run like that.
So in this particular case, when counter is divisible by 2, we print out. Then else, if you don't want to do anything, then you have to use this word here, continue. As you can see, it's green. This means that it's a keyword. Python knows what to do with that. So basically, it will just take the control back to the beginning of the loop in this particular case.
So this is an example of you have a bigger loop while inside that you have the if else
Yes.
statement.
Yes. So we can actually put the if else statement inside while we practice.
So
Okay.
before you go,
Before you go,
put one there
Where?
on if counter divisible by 2.
I put
is equal
one
to
here.
1.
Okay.
yeah, like
Yeah.
how
So
to
this
put
one-
in the odd numbers
So
now.
now this one, if you put 1 here,
Uh,
then this one will print out odd numbers.
okay.
So the only thing we need to change is the value equal to
Yeah.
them. If you want it to be even numbers, you put 0. If you want it to be odd numbers, you put 1. Okay. So this is how you control a while loop using a counter, a value you can increment inside. But sometimes, and when you do this, you already know ahead of time how many times your loop is going to run. But there's times when you don't know how many times the loop is going to run, and you want the person who is running your program to determine when it's going to run. So you tell them, if you want the program to quit, enter a particular value. That value which they're entering, that's basically called a quit value, or that's also what is called a sentinel value. So a sentinel value is basically a value which a person has to provide so that the while loop gets stopped. So in this particular case, we'll type a message with this tiny program. Basically, you type something, then it repeats whatever you have typed. Then if you want to stop, you have to press Q, small letter Q. When you press small letter Q, then it stops. So here, this is a print message for whatever is going to be typed, want to print out. Then this is something called the prompt. So this is a message which is going to be displayed to someone. So it says, tell me something, enter Q to quit. So this Q, this is what is called the quit value or the sentinel value. So we'll be checking against that, whether the message the person has entered is Q or not. If it's not Q, then we print out the message. If it's Q, then we try to quit. So the message in this particular case, we start out with an empty string, almost the same thing as a counter, but now here we've got an empty string. So now what we will check while message not equal to Q. So if the message is not equal to Q, then we want to display this message. So input, then prompt. So we want to display this message. Then after we display this message, we want to give the person space where they can type. They type, then we collect that information they're going to type. We store it in message, then we print out the message in this particular case. So when I run this, so it says here, so this program repeats a message entered by user until the user types Q to quit. So here, I'll start by typing hello. So if I type hello, that hello is going to be stored in message, then it will be printed out.
So, Mr. Son,
Yes.
just before you execute there, this program repeats a message entered by user until user types Q to quit. These are statements that you are putting in your program, right? By yourself.
Yeah.
Yeah. So maybe that need to be specified for students so that.
Yeah. So
These
if I
are comments actually.
Yeah, you
that
put your
we
comment.
do. Yeah. Just to
there's a comment up here.
Oh, that's.
There's a comment up
Yeah,
here,
okay.
but there's also just this.
Yeah, that
Yeah.
one.
Since the comment is not displayed, so that I can. So yeah, so that we can
Right.
the function of the whatever is happening here. So if I type hello, I print enter. Then after I type hello here, it repeats the hello. If I type welcome, it repeats the welcome. So it prints out the welcome again.
Until you type Q.
Until I type Q. Now, when I type Q in this particular case, it stops. But you can see it has repeated the Q, which is not something we want, because now it's treating the Q as a message when we actually want to quit. So in order to sort out this problem here, we have to check what kind of message has been typed. So in this particular case, we make a small improvement before we print. So here we just, after the message is received, we printed it out. So instead of before we print out, we need to check the message, and that's what this part is doing here. After we receive the message, we check if message is not equals to Q, then print. So this is another if thing we are putting inside the while loop. So we check that if the message is not equals to Q, then you print. Otherwise, if it's Q, just don't do anything. So in this case, you type again, hello. That's what you get. Then welcome. We have that. Now this time around, if I type Q, then it doesn't get printed out, because before it prints out, it needs to check if that message is not equals to Q. That's when you need to print. So that's basically how you sort out that particular bit. So that thing can run for as long as you want. And yes, Dr. Mne?
Essentially, that's a message to our students. Basically, the importance of this is, for example, in finance, if you go on the ATM prompts, type your password. These statements like this. Okay, you put in your password, it checks if your password is not same as another customer. If it finds it's not like that, then it allows you and you proceed and get your money. So these things, physicists, we can do. You don't have to be limited. Like no.
Actually, ATMs are just computers, isn't it?
Yeah.
Okay. How can you exit a while loop? Well, there are two ways you can do that. One of them is to use something called a flag. Now, a flag is a variable you set to a true or false value, and if it becomes false, then you want your while loop to come out to stop, or you can use something called break. So in this particular case, our same message, in this particular case, I need to just copy something. I need to copy these two lines. I need to copy these two lines and put them here. Okay. Okay, there. Now, in this particular case, instead of us checking message not equals to Q, okay, we set a particular variable which is called active here. This is a flag. We set this variable to true. Then this variable which we have set to true, we use it as the condition. So we say while active, and active has got a true value. So it's true. So the loop is going to run. So if you want to stop, we'll need to have a way of changing active from true to false. So in this particular case, we prompt for the message which we want someone to type. Then after the person types the message, we check here. If message is equals to Q, then we change active to false. Else, we print the message. So this is one way of quitting or okay. So in this particular case, if I run this, I have hello, then welcome, then the other one we can say goodbye, goodbye. Then if I press Q in this particular case, then it quits. So this is another way of quitting your loop by using active. The other way you can do this is you can hardwire the true. So here we're using a variable active which we change to true or false. Or the other way you can do that is you can literally just hardwire the whole thing. You can just put while true here. Like that. So let me copy this part. So if the condition is hardwired, which is not good, but it doesn't mean you can't do it. If the condition is hardwired like that, then if a person types quit, message equals to quit, then the only way to get out of this loop is to use something called a break statement here. So you type break. So this break statement, if the condition, if the message is equals to quit, this break statement will make sure that you get out of the loop and it stops.
Mr. Sujan, I'm not getting. That true, where is it defined then? Why true? What does...
This true is a value. It's a Boolean value. It's like a constant. It's a 1.
This one is already embedded in the program.
It's known in
That's why
the programming language. That's why it's green like that.
So these functions are already there.
So this value of true, that's how Python chose true or false. So if it's true like that, if we don't do anything, it will continue to be true, so our loop is going to continue running like that to infinity. So it's basically it becomes an infinite loop. So we need to embed a condition, say if message is equals to quit in this particular case, because we can't, if we have hardwired it like this, we can't change it. The other example we have on top, we had a variable which had this true. So we could change the value of the variable. So in this particular case, we can't change the value of the variable, so we need to break out of the loop. And that's basically what this particular bit here does. So here, hello, welcome, goodbye, goodbye, thank you, like that. So,
Just a question.
mhm.
Maybe from first one, where we are printing some numbers from 0 to 9. Is there a way to time when it's supposed to display? For example, you want to display every second, space 0, 10, 1, 2, 3.
I
Yeah,
think
yeah, there's a timer.
there's a way you
There's
can set a
clock.
time.
There's a function called clock. And
Yeah, you can-
I don't know in,
I think there should be a
Python,
clock here,
but
so,
we see it's
which
there.
does something
Yeah.
before you do the printing. So there's some function you can insert before the printing of everything, which runs for a particular amount of time. Then
In fact, Dr. Mdenda's question is pretty very good question, because certain programs may run for a week. Supposing a project is supposed to expire in 3 days, how are you going to do that? Or maybe you don't want to be visiting to see all the time it is running. So you would set it for a certain time so that it's marked at that time. The program stops.
It works even with PowerPoint. You can tell PowerPoint, okay, after 10 seconds, release the next slide. It's the same thing.
okay, so in the interest of time, since I only have 20 minutes left, this part, what you can do, other things you can do with while loops and data structures. This one I will skip it. Or let me, I don't know if I can push it, but no, let me just skip this part. Let me move on to the for loop, which I think can do most of these other things also. So the other structure we can use for repetition is the for loop. Now the for loop is pretty straightforward in this particular case. You can use it to loop over data structures so that you can see the items in this particular structure one at a time. So here we're going to loop over a list. And what we have here basically is we have created a list called prime numbers, and these are the prime numbers which this particular list contains. So in this case, for loops for Python are a bit different, slightly different from a language like C++, where because other languages you have got a part where you are initializing the iteration variable, then you check the condition, then you increment it like that, then you carry out whatever it is. In this particular case, for Python, the only thing you have is you have your variable here, then in, then prime numbers. So what this statement here is doing is the prime numbers is what we have here. So it will be picking one value at a time from here. It picks 2, it stores 2 in number, then you print out 2. So that runs. then it picks 3 from prime numbers, it stores it in here, then you print it out, then it picks 5 from this structure, then it stores here, then you print it out like that. So basically that's what for loops here do. They basically, it's a way to pick items from a data structure one at a time. Then you can do whatever you want. Either you can print them out or you can do some calculations. So in this particular case, when you run this, then this is what you end up with like that. 2, 3, 5, 7, 11 like that. So it picks items from this structure one at a time, then it stores here, and then you can print them out like that. Apart from just printing out, you might want to do some calculation with the numbers you're getting from this particular list. For example, you might want to square these values. So in that particular case, we create an empty list called squares, which is this one here. So we do the same for loop from this particular structure. We'll be picking one value at a time, and when you pick a value, we'll store it in number, then we square here. So this is a power function, so this is a built-in function. So basically this says number to the power 2. So whatever value you've obtained from here, we'll square it, then the result we're going to store in a variable called square. Then after we store the variable in the variable called square, this value will add it to this list. So basically the way you do that, you say square dot append, then the value you worked out here. So we'll start adding values we have squared. These values we have squared them, we'll add them to this list called squares. Then after that, we'll print out squares. So we do that, we'll run this, so we end up with 4, 9, 25, 49, like that. So these are the squares of these prime numbers there. So you can, apart from just printing out things, you can actually carry out some mathematical operation with the values which you have in a list like that.
So it's the same like if you want to do cube root, you can just say power number
3. Yeah, 3. If you want to do cube
And
root, we just put 3 here. We just put 3 there. Then if you run it, then now you have 8 like that. Yeah. So you can actually, as you are going through the data, the information in the data structure, you can carry out some operation, then do what you need to do. You can also loop over a tuple. A tuple and the lists, they are basically one and the same thing. The only difference here is that for a tuple, you cannot modify the items in a tuple. And again, the loop looks identical to the other one, where you pick this item value, store it there, then you print it out, then you repeat the same process like that, and basically that. So basically for a tuple and the lists, the operations are basically identical.
What's the difference between this one and the previous one?
For this one, it's this. These are parentheses.
This one was square.
Yes, the first one was the square, the squares.
Okay.
So this is called a list. The major difference is that for a list, you can modify the items in the list. For a tuple, you can't modify the items in the tuple. If you are interested in the position of the item, because those items there have got something called an index. So the first one here has got index 0, second one here has got index 1, index 2, index 3, index 4, index 5, index 6, like that. So if you're interested in the position of an item and the value of the item, then you can create something called an enumerated object. And the way to create an enumerated object is to use a function called enumerate. So here, this is my prime numbers list. Then I print it out. That's what I have. So I give this particular data container to a function called enumerate. So this enumerate is going to create for me an enumerated object from there. Then I'll store it back. I don't know whether it's storing it back to enumerate is a good idea. Let me say let me say enum here, like that, so that we can see that there is a bit of a difference, like that. So so that is short for enumerated prime number. Then now when I check what I have here, enum, enumerated prime number. Now it tells me what I have is something called an enumerate, or basically an enumerated object. If I give this enumerated object to a function called list, what you're going to see is the following. So you're going to see a list like this, but you have the value and the index being paired. So the value and the index get paired, and this is what is called an enumerated object. So this is the index, this is the value. This is the index, that's the value. This is the index, that's the value. This is the index, that's the value. Index, value, index, value, like that. So here we have created an enumerated object. So if you want to loop through these, the index and the value, then your Python, your for loop will need to have two variables to receive the index and the value. So the first one in this particular case, the first variable will receive this one, and the second one will receive this one. So this one is the index, and the variable which is going to receive that is this one, index. Then the second one is this variable which is going to receive the value. So here, let me change this to enumerate that. Okay, so here, same, prime numbers list. Then we create an enumerated list from the from there. Then we'll go through this enumerated list. So it has got two values per thing, the index and the value. So the index goes there, the value goes there. So if you want to print out now, in this particular case, we'll do that. So we end up with this index 0, value 2, index 1, value 3, index 2, value 5, like that. So this is how you will be able to access paired values.
In the format, if you change the value to the left and the index goes to the right, then still it works, just the format changes, right?
Yeah, so in this particular case, if I check, you want me to swap the...
Swap the value of the index.
Okay, so if I make a swap, which means here, basically, I'll do here, I swap value here, I put value there, then I put index here. What did I do?
But
No. Sorry. Yes, fine. Index, then value here. So the swapping is done here.
Yeah.
So if I swap them here, no.
It's not in the print.
Here, you just leave it the way it is. We swap. So here, the first is index, then the second one is value. So when I swap them, now I have value and index. So the first item, the index is now going to be stored in value, then the value is not going to be stored in index. So the swapping is done there in the follow. Okay. So now when I do that, now this is what I have. So now you have your index having 2, which is not correct, and your value.
No, what he meant was this.
Yeah, I mean in the printing.
Oh, if you swap in the print.
Yeah.
Okay, fine.
No, that's okay, but the print.
If you swap in the print,
Not there.
Not there.
Not there, the print.
wait, here.
It was okay, you should just have changed in the print. Yes, in the print function.
Okay. No, this is what is called a string format.
Look at your answers.
Mhm.
2 is the value and 0 is the index.
Yes.
So when printing out, you should have said value,
Value
is 2,
and then index.
is 0.
Yeah, but that's not the purpose for this part. The purpose for this part is to say, when you swap these things, the index is always going to go in the first one you have listed, and the value is always going to go in the second one you have listed. That's the purpose of that.
Okay, now we
We
want it.
understand, we are looking at your answer and what
Now I want it to
Dr.
be
asked.
correct.
No, the correct one is the one up here.
Yes.
This is the correct one.
Now I want you
Just
to be
check.
like
Now we
If
just
this
want
you can make
value
this
is equal,
correct.
value to index 0. That's what we need
So
now.
just
Yes, yes.
Look at
I will have to
it.
rewrite
It's supposed
this.
to be
Yes,
index.
that's
I'll have to rewrite this.
Yeah,
So-
can you change
So,
Yeah.
so the way you change that is you change here. It's to change here. I swap these ones. I don't change these ones because this is a string format. You don't change the string format, but you change.
changed it, but still it
Could
is
you
not
try?
coming.
Could you
Let's
try
try.
the section, put value here and index there? Let's just see what happens.
Let me first show what I'm trying to do here. There.
Yeah.
Let me change there. So if I change here, I put index, and I put var here. Then you see that. Oh, what about value?
So this is what we're saying in the print. Just swap the two index and value. Then what,
Then they should be able to.
what Dr. Milo is asking
Okay.
will work out.
Mm.
We are not arguing about your first correct form. We are
Yes.
just mentioning that
Yeah,
to
that way.
get the result he wants, you have to do this.
Okay.
Then
I need-
format also, it needs to
No,
be the
it's
other.
okay.
It doesn't
No,
matter.
no.
Yes,
Okay,
there
sorry.
it
Okay.
Yeah.
So that means that format, what is it doing there?
The format is how you want it
This is
to come out, right?
how you want things to come out. So basically here we are saying print out value like that. Then this is a placeholder, like when you're that English fill in the blanks. When the teacher draws a blank line where you're supposed to write a word. So that curly brackets is a placeholder. In C or C++, the placeholder is percent, the percent thing in other languages, percent D or percent A's, but for Python you just use these placeholders like this.
The problem is, in your format, it is still appearing as index, then value.
That's what I'm asking. If we have changed the print now, now if we change the format also to value and index, what is
What
happening
does
now?
it?
There
It will
also
swap
you
the
swap.
answer.
It will swap the answers because we have swapped here, because the things are swapped here.
So format is a function already in the programming language Python. So there's
Which
already
works with,
which we can't
Which works
control.
with strings. So basically it's a method which works with strings. It's a string method.
Yeah, yeah.
Okay, so similarly for a tuple, it's same thing. So probably the thing I think of interest is something called a range. A range objects, in this particular case, with the problem we're trying to work out, where we said let's produce even numbers. This line here produces even numbers from 0 to 20, and that we'll see how that it does that. Then you ask the type, it tells you it's a range. Then you do a print of this thing. This is what you get. You don't see much, but if you give it to list, this is what you have. Okay. So there's actually a more compact way of producing even numbers, like this, by
Why
using.
21?
Sorry,
Why 21 then?
21 is excluded.
Ah,
Start from 0
less than
up to,
21.
but exclude 21 from the creation of this particular list. So this is a quick way of producing a list which contains even numbers.
What about if you put 3 there?
Where?
Yeah, instead of 2.
So
the
here-
range. Yeah.
So if you want to stay in steps of 3, so if you do that, so you that's what you're going to get. So it will be 0, 3, 6, 9, 12, 15, 18, that.
What about if you want to say prime numbers?
Prime number.
Or maybe it's
Ah,
a bit
Ah,
complicated.
it's difficult. It's a bit difficult. You have
Yeah,
to.
supposing you want to include 21, Mr. Stone. 21, you want to include it. Is it possible?
You have to make this one 22.
You just change it. to-
Yeah, you have to make it 22.
So the range, you don't have like the square brackets, which includes, because in mathematics, when you define a range,
Yes.
you use square.
0 to.
Yeah.
Now here you just use this particular function range. So you can tell it how you want your range to be.
So the range has to be in the middle.
Yeah, that's the
The
The function.
cutting number has to be in the middle.
Middle.
Sometimes it doesn't take this one. Sometimes if you don't include the 2 at the end, then it produces a range in steps of 1.
Yeah,
Automatically produces the steps in steps of 1. So if you include the third one, that is what is called the step size.
So this can be good when you want to plot a graph. So
Yeah, if you want to plot a graph,
define the
yes.
x-axis.
Yeah.
So from 0 to
Yeah,
whatever,
yes,
then
yes.
the step is 0.01.
Yeah,
Yeah.
do that. So this is a start. This is up to but exclude 21. Then in steps of 2.
Is this one good? Did you try square brackets? Will it work? Or
Here,
Hmm.
where do you put the square brackets?
Here, it will fail to work, right? If you use, where is the range? Here, if you use square
It's
brackets.
a
No, it's a function.
method.
It's a function.
So, you can
So functions have parentheses.
Oh,
You can't do anything.
Yeah, you can't
But
use
this
it.
is not done with tuple.
Obviously, you can find.
You can find there's a function tuple also, which creates tuples from lists. Yeah. But when you are trying to create from scratch, if you're creating the thing from scratch, a list you have to use square brackets.
Square
For a
brackets
tuple, you have to use those parentheses. Yeah. But this is a function. So we have seen that this particular one here creates. Wait, we put it back.
I don't know how well we are doing with time.
We are almost.
we are
Almost done, yeah. It creates this particular bit here. So if you put it here for number in ranger, it's the same idea. So it will be picking from here. It picks this one, puts it in number, it prints it out here. Picks the second one, puts its number, it prints out here. That's basically the main idea with for loops, and you end up with something like that. Last but not least, these are dictionaries. This is a dictionary for weekdays. So here you're matching the key, which is 1, with the value Sunday, then 2 with Monday, like that. So basically this structure, or this data container, is called a dictionary. If I print type here, it tells me this is a dictionary. I can print it out like that. So you can go through this particular dictionary also. Now in this particular case, when you use a for loop this way, we say for key in weekdays. From weekdays, which is the dictionary, what you're going to retrieve is this one. It's the numbers, the keys. So using these keys, you can now access these values. So you say for key in weekdays, then you print key. When you print key, you only access the numbers like that. So if you want to access the values, you have to use the you have to use you have to do this. So for key in weekdays, then you use weekdays key. That's going to give you a particular value. Then you can print out that particular value. You see this? You have to use a key to access a particular value. Then once you have that value, then you can print it out like that. So if you do this, this one now prints out Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, like that. Okay. So basically, I think that's the end here. There's other ways. We have. I think when we looked at dictionaries, there's other ways to access the values, and we did that. But basically, that's the main thing when it comes to repetition in this particular case. Any questions? I think we've come to the end. 11 hours exactly.
Before you close this
Okay.
online.
So maybe for next week we'll do a new lecture.
Next week we'll have a new lecture, yes.
Okay, so next week we will post the abstract.
Yes, since this one was a continuation of the last
Yeah.
one.
Okay, otherwise let's continue encouraging all students in whatever class, undergrad, masters, to join us. Because as we have seen, Python is a good tool not only for our physics activities, mathematics, even people who just want to write programs for fun.
Yes,
they
yes, I
can
have
do
it.
it. And this world is now about skills. If you have a certain skill, you can make money even without a permanent job. Thank you very much.
You're welcome.
Even even for gaming, Mr. Nambala.
Yes. Yes.
Children are doing a lot of games.